All right, let's talk about making a huge leap. We're going to bridge that gap between knowing a few basic Linux commands and writing truly professional, production-ready shell scripts. The kind that real DevOps teams actually rely on to keep everything up and running. So I want you to ask yourself this question, honestly. Do your scripts just kind of work on your own machine, or are they actually production ready? Because believe me, there's a world of difference, and making that mindset shift is exactly what we're going to tackle today. So here's our game plan. We'll start with building a solid foundation, then get into debugging and how to handle data. After that, we'll cover how to control your script's flow and look at some pretty advanced safeguards. And to make it all stick, we're going to build a real-world node health script, piece by piece as we go. First things first, the professional script foundation. This is all about building for reliability. It's what separates a one-off command from a reusable tool that your entire team can actually trust. It's funny, professional scripts don't even start with code. They start with comments. That very first line, the shebang, is absolutely critical. It tells the system exactly which interpreter to use, like /bin/bash. This one little line prevents all sorts of weird, hard-to-diagnose errors. Then you add your metadata, who wrote it, when, what it's for, and the version. It makes our node health script something anyone can pick up and understand. Okay, this one is a total non-negotiable for production scripts. Just imagine your script needs to stop a database, then delete attempt backup. Well, what if the stop command fails? Without set E, the script just keeps going and, whoops, you've just deleted the backup of a live running database. Not good. With set E, the second that first command fails, the whole script stops. Dead in its tracks, it fails fast, and it fails safe. But set E has a bit of a blind spot. Command pipelines. If a command fails somewhere in the middle of a chain, set E, by itself, might not catch it. And that's where its trusty sidekick, set O pipefail, comes in. It makes sure that any failure anywhere in that pipeline brings the whole script to a halt. Next up, let's talk about debugging and readability. Because let's be real, scripts aren't just for machines. They have to be written for humans, especially when you're the one trying to figure out what went wrong at 3 in the morning. Oh man, we've all done it. You sprinkle dozens of echoed statements everywhere just to see what's going on. It works, I guess, but it's so messy. The professional move is to use set-x right at the top. This little command automatically prints out each line of your script right before it runs, giving you this perfectly clean execution log. It's debugging made easy. All right, on to section 3, mastering text and data. This is really about finding that one tiny needle in a giant haystack, which honestly is a massive part of being a DevOps engineer. I mean, this quote just says it all. So much of the job is just sifting through these massive walls of text, from logs, from command outputs, from APIs, all to find that one tiny bit of info you can actually do something with. So let's look at a classic example from our node health script. We need to find a specific process ID. You start with ps-ef, and boom, a giant wall of text with every single process. Too much noise. So you pipe that to grep Amazon to filter it down to just the lines you care about. Better. Now you pipe that output to awk print2, which just grabs the second column, the PID. And just like that, we've whittled down a mountain of data to the one single number we need. The magic that makes all of this work? It's the pipe character. It is the absolute superglue of the Linux command line. It takes whatever comes out of the command on the left and shoves it right into the command on the right. It's how we build these incredibly powerful laser-focused command chains. So here's a classic interview question that totally tests if you get this. Why doesn't date echo today actually print the date? Well, it's because the echo command is designed to completely ignore anything piped into it. It doesn't read from standard input. It's a clever little trick to see if you really understand how the pipe works. Now, when you're grabbing data from the network, you've got two main tools, curl and wget. The dead simple way to remember the difference is this. Curl is for viewing. You use it to check an API status for your health script right on the terminal. Wget is for saving. Its whole job is to download a file and put it on your disk. View versus save. Simple as that. Okay, let's talk about giving our scripts a brain. Controlling script execution is how we let them make decisions and repeat actions, turning them from a dumb list of commands into something smart.
The absolute bedrock of decision-making is the if-else statement. It's just like it sounds. If this condition is true, do this thing, else do this other thing. So for our node health script, that's like if the disk space is over 90%, then we're going to send out an alert.
And when you need to do something over and over, the for loop is your best friend. It's the engine of automation. It lets you run the same block of code for every single item in a list. For instance, our script could use a for loop to run a health check on every single server we have listed in a config file.
Time to level up with some advanced safeguards. These are the tools that make your script tough enough to handle all the weird, unexpected problems the real world is going to throw at it.
Okay, picture this. Your script is running. It's right in the middle of writing some really important data to a log file. And then someone hits Control-C. The script just dies right there, leaving that file half-written, totally garbled, and completely useless. This is a super common and really dangerous problem that most simple scripts never account for. And the solution is a command called trap. This thing is a lifesaver. It lets your script literally trap a system signal like the one from CTRL-C, and instead of just dying, it runs a special cleanup function you wrote. This means our node health script can delete its temp files or write a clean exit message, preventing that data corruption every single time.
Look, on a big production server, you're not always going to know where stuff is. The find command is basically your search engine for the entire file system. It's like a bloodhound that can track down any file based on its name, size, when it was last touched, you name it. It's a tool you'll use all the time.
So let's wrap this all up. This is about taking all these technical skills and connecting them to what it really means to think like a professional DevOps engineer.
So what are the big takeaways? First, always write for safety. Use robust error handling in commands like trap. Second, write for other humans. Use metadata and set X so your scripts are easy to debug. Third, write for automation by becoming a master of text processing. And finally, you have to practice this stuff. These aren't just academic concepts, this is the core of professional scripting, and you will see this stuff in job interviews. And that really brings us to the most important idea of all today. Good scripts don't just work, they actively protect the systems they run on. And that is a fundamental difference between a simple list of commands and a true production-ready tool.